Good morning, ladies and gentlemen. This is John Belkwitz from Intelligent Concrete, doing our episode 2 coffee talk. We're over here in Salt Lake City, Utah. As you can see, I got this makeshift studio here, but we're making it happen. And we're continuing yesterday's discussion on dosing high-range water reducers for concrete. And just as a reminder, we had a concrete mix design. We're assuming it's a self-consolidating concrete. We're using about 650 to 720 pounds total cementitious, 0.35, 0.38 on the water cementitious, 1250 pounds per cubic yard in the sand, 1350 on the rock, and that's going to be your 3/4, 6757, and then we're also throwing in a pea gravel at 300 pounds per cubic yard. Air entrainment was a half ounce to 1 fluid ounce per half ounce per cement hundredweight. And then our high range was around 6 to 8 fluid ounces per cubic yard, or fluid ounces per hundredweight. Sorry, we had an early wake up this morning to get some work done. Now, all of this was for a concrete to make a flow of about 26 to 30 inches. And I know that's a wide range, but it's really going to be dependent on how good your high range is and how well the salesman or salesperson did to marry up your high range with your cementitious type. But so part 2 is really identifying what happens when that dosage doesn't work. So if you're trying to look for that creamy and dreamy 26 to 30 inch spread for somewhere around 90 minutes to 2 hours, and your 6 to 8 fluid ounces per hundredweight, if your high range did not work, there's a few steps that you want to use. Now, when I say does not work, either it's too tight or it's way too loose. And unfortunately, when your SCC is way too loose, there's only so many things you can do. Stop the truck, stop it from rolling, let it tighten up a little bit, then go at it again. You can always put a cubic yard or a certain dry amount of material on top of it. But the first thing, or the other direction, is that it's way too tight. It's a chunky and monkey, and it's sticking to the sides of the drum instead of flowing over the fins. So there's 4 things that you want to do in both situations. First, check your batch tickets. Make sure what you ordered is what you got. Sometimes you'll find that the tolerances were not met for whatever reason. A valve wasn't working, a gate was stuck open. Whatever the reason, you should see those tolerances on your batch ticket, or your batch weights that you should get with the truck that you ordered. The other thing is check your unit weights. The concrete was tested. You want to check your air, check your temperatures. There are these tests that we have in the industry to help us identify if we are making those weights, those fresh properties. Your temperature test, your 1064, your slump, but there's also your unit weight and your air content, and those will tell you a lot. For some reason, if your driver put water into the truck that wasn't calculated on the batch weight or the batch ticket, then will you see that added water, if, let's say they were washing the fins or something, is in your unit weight. Your unit weight should be somewhere around 130, 145, depending on what type of concrete you got. And if it's excessively low, there's an indication. The next thing is your temp, if your temp is low or high. And then air, if your air just exploded, that might make your slump go a little bit crazy. So let's say your slump is fairly tight and everything was nice, and you need to get it back up to that 28 or that 26 to 30. There's 2 different directions you can go. You can either add more high range or add a little bit of water. Advantages, disadvantages for both. So adding more high range, yes, it will give you more flow, and more than likely it's going to give you a longer slump life or slump evolution. The disadvantages, adding more of that high range can also make your mix sticky and nasty. This is not true with all high ranges, but more often than not, you add more of that chemical and you're going to get that sticky, which is going to have a detrimental effect with your laborers, with your folks who are finishing the concrete. And then if that high range is not mixed entirely through, you could have soft spots in your concrete. Now, going on the water side, the advantage is you can get more flow. It is the inexpensive and easy way to get more flow, especially on the job site if your driver's there and you don't have a seasoned tech who has the chemicals out there. Disadvantages, you will have a greater tendency for segregation, and you will have that with the high range, but more so by adding water, since every addition of water is going to be so much more sensitive. And then the other piece is that as you add more water, you are going to reduce your early and later strengths, and that's just the nature of the beast. So hopefully this helps you out in the field. Shoot us any questions through direct message or any of our photos or our posts. Hope you like those articles out there, and let us know if you have any questions. Don't forget, we're the experts in the industry. Go concrete, beat asphalt.